Next topic that's been changed in NEC is around surge protection. And I'm going to ask Mike to go ahead and lead the conversation on that piece.
Okay, thank you, Phil. This is a significant change in Article 230. Section 230.67 is new, titled Surge Protection, and it's required for services supplying dwelling units, and that's pretty broad in application. 1 and 2 family, multifamily, single family, so this would apply. And really the code is responding to an increased need to protect electronics within the dwelling unit that are necessary for safety, such as the electronics within GFCI and ASCI devices, the electronics in smoke alarms, some fire alarm systems that include smoke detectors and heat detectors. There's a lot of electronics that are used within the home these days, and this is a safety-driven change to protect the electronics within that equipment. The requirement is such that the surge protective device needs to be located at the service equipment. It's either integral to the equipment, it can be installed inside the equipment, or immediately adjacent thereto. And there's also an exception to that general requirement that would allow it to be located at the first level distribution equipment downstream toward the load, such as at a panel board, for example. It's a type 1 or type 2 device, either on the line side of the service disconnect for connection, or on the load side of an overcurrent device at the service. Those are the 2 types, and of course they're required to be listed.
This is also going to require that there's a first level subdivision that gets into replacement. So where you're doing a service upgrade, you're going to have to provide a surge protective device. In the past, it's always been an option for the homeowner, but now it's going to be a requirement. And as Mike pointed out, it will protect all of that sensitive electronic equipment in other areas of the NEC that is designed to protect the occupants of the dwelling.
Yeah, and certainly as we think about where we connect this, you want the shortest connection possible to have the best performance of your surge protective device. And if you don't install it at the service equipment, then you would need to install surge protection at each distribution point downstream, so at sub panels downstream as well, if you don't supply it there at the service.
It's always a good practice to have 2 levels, where at the incoming service and that at the point of use. It's typically going to give you the best protection, but Jim makes an excellent point about the retroactiveness in subdivision D. The NEC is not typically a retroactive document, but in the interest of safety, if you're doing a service upgrade or putting a new service on, for example, this requirement would be triggered.
Yeah, speaking of new changes for safety, for 1 and 2 family dwellings, we now have a requirement for an outside emergency disconnect. And this disconnect was really driven by emergency responders and fire service personnel so that they have a way to terminate all service conductors and remove power from a residential 1 and 2 family dwelling so that they can safely do operations. And the equipment has to have a short circuit current rating equal to or greater than the fault current, and it's got to be in a readily accessible outdoor location. So this emergency disconnect can take many different flavors depending on what other roles it might serve. But the primary role here is for the fire service and their ability to remove power from a dwelling. It's a safety issue so that they're not trying to pull meters or anything like that to remove power for a dwelling. They're not having to wait on the fire service on the utility to show up and cut power to the dwelling before they perform operations. So this is one of those changes that is obviously very impactful, because now you've got an outside disconnect at a readily accessible location for all 1 and 2 family dwellings, but it's also in the name of safety. And I think for emergency response personnel, this is an important change.
Yeah, and if more than one disconnect is provided, they do have to be grouped together, and we specifically outline what you can use. Another revision here that is outside of Article 230 that comes into play is there's requirements in Article 445 to shut down the prime mover of a standby generator, for example, that may be supplying an optional standby system, and if the dwelling unit had an energy storage system. So Article 706 is going to require a disconnect, and in that case, we're going to tell you that you have to take that disconnect for that energy storage system and install it at the service disconnect so that the firemen can get there, or any emergency responder, and remove power from the building before they go in.
You know, that's a great point, Jim, because also with solar installations in a residence, you have the rapid shutdown requirement. And so these disconnect functions perhaps could be consolidated, right? And one disconnect performs several functions, but it's clear now from a fire service response, emergency response, that they need that access.
Yeah, and there's multiple ways that you're going to be able to do this. It could be a service disconnect. So in areas of the country where we put the panel board outside, then all you're going to have to do, it's going to be done, but you're just going to have to label it emergency disconnect, service disconnect. You can have a meter disconnect upstream, and you'd label it emergency disconnect, meter disconnect, but not service equipment. And I think one of the most popular ways to get it done is going to be taking SE cable into a meter housing and having a device, because list item number 3 permits other listed disconnect switches or circuit breakers as long as they're suitable for use as service equipment. And in that case, you would mark it as emergency disconnect, not service disconnect. So what that means is inside that meter enclosure, the housing that I get for the circuit breaker, I don't need to take a grounding electrode conductor. Right. And I don't need to take an equipment grounding conductor into the dwelling unit. So I can come in with SE cable, leave with SE cable, and the disconnect in my panel board becomes my service disconnect.
And that's where you would land all your grounding electrodes and bring all of those bonding provisions to, just like you do today.
Yes, and that would allow the installer to land the equipment grounding conductors and the grounded conductors, the neutrals, on the same bar. If we treat the disconnect outside as a service disconnect, then when we get inside, what we have is at that point we have a feeder into a panel board inside the home, and we need to isolate the grounded conductors from the equipment grounding.
So we're going to have we're going to separate the neutral and separate the grounding conductors in that panel instead of landing them on the same bars.
Yeah, if you choose to do it that way. Yes.
Yeah, and one more item in the marking piece. It's really clear that the outside marking of the product is where you have your emergency disconnect marking. Jim walked through all the different scenarios as the function of the disconnect switch, but as far as the marking, you want something that is readily accessible and readily visible even at night for the fire service. So red background, white letters, emergency disconnect is what you'll see on the outside of the enclosure, regardless if the handle of the disconnect is actually inside. This will be on the outer cover of the enclosure.